Okay, here's solutions to perfect problem 1 from Math 65. In this problem, we're asked to find the solution that satisfies this system of linear equations, and we got to do it 3 different times using 3 different methods. First one, graphing. All right, so to graph these equations, we want to write them in y equals mx plus b form. Let's see this top guy here. If we were going to solve this guy for y, got a few options. See, one way to do it would be to add the 2y over to this side and subtract 6x over to this side. What I mean by that is get 2y plus 6x equals 12. And the way I got to here from here was just adding 2y to both sides of the equation. And now we'll subtract 6x from both sides. And that gets us to this step. And so now we've isolated 2y, but really what we want to do is isolate y. So what we'll have to do is divide both sides of the equation by 2, which gives us our line in y equals mx plus b form. If it helps you, you can even write that the slope right here is -3, or some people like to write that as a fraction, -3 over 1. And our y-intercept is 6. And now if we do something similar on this second equation here, let's see, again, we want to isolate y. I think this time what I'd do is maybe add 1/2 to both sides of the equation, and that gives you this x plus 1/2 equals y over 2. And just since we're so used to having the y on the left-hand side, maybe I'll write all this stuff over here and all this stuff over here. Right? The equal sign you can kind of go either way with. So going from this step down to this step, all I did was write this equals this. That's what I got here. So now what we've managed to do is isolate y over 2 right here, but what we want to do is isolate y. So to get y all by itself, we'll multiply both sides of this equation by 2. And on the left, that'll just leave us with the y. And on the right, we'll get 2 times x is 2, and 2 times 1/2 is 1. So now we have this equation written in y equals mx plus b form. The m is 2, or if you prefer, 2 over 1. And the b is 1. So now if we graph these two equations, hopefully we'll be able to figure out where the intersection of those two lines are. Let's see this one. The y-intercept is 1. So if I go up 1 right here, I got a point. And the slope is 2, so that means if I go up 2 more from there, up 2 over 1, I get another point. So from here, up 1, 2 over 1. And then if I connect those, dots with a straight line, straight-ish line, we get our red line right here. Maybe I'll graph this line in blue. Let's see, now we got our y-intercept, b is 6. So 1, 2, 3, 4, 5, 6. And so that tells us we can put a point right here. And our slope is -3, so we want to go down 3 over 1. So from here, down 1, 2, 3, and over 1. And sure enough, it looks like we land on that same point. Connect those dots with a straight line, we get our point of intersection right here. Maybe I'll make that in green or something so you can see it. And that green point right here is when x equals 1 and y equals 1, 2, 3. So from graphing, it looks like our solution is 1, 3. But what's kind of nice about this problem is we can check that solution because when we were supposed to do this problem 3 times, right? We just did it with graphing. Now we have to do it with substitution. And hopefully we'll get the same answer. Let's see, scroll down a little bit. Substitution. So let's see, you have some choices here. It might be smartest to start back over and use these 2 equations. Although I bet what a lot of people will do will start right here for this equation and here for this equation, because then that'll make the substitution even easier. But just in case you didn't see that little trick, I'll start from the start just because I think that'll be the harder way to do it. And I want to make sure you guys got solutions that are as helpful as possible. So I'll start with that 6x equals 12 minus 2y for our first equation, and x equals y over 2 minus 1/2. And what's nice about this problem from a substitution viewpoint is that x is already solved for. We've already isolated one of the variables. So I think the most straightforward thing to do would be to use this equation, but instead of writing x here, write what x is equal to from this equation. So we get 6 times, then instead of writing x, you write y over 2 minus 1/2. Right, so 6 times x is all this stuff, equals 12 minus 2y. You got other options on how you do this, but this is probably the way I think would be the most natural. Let's see, if you think of this 6 as 6 over 1, we'll get 6y over 2, which is the same as 3y. Maybe I'll write an intermediate step in here just in case. 6y over 2, and then 6 over 1 times 1/2 is 6 over 2. Again, you're thinking about this as 6 over 1. And that equals 12 minus 2y. And now we can cancel out from the 6 and the 2 and make that a 3y. Cancel out this 6 and 2 and make it a 3. And you get 3y minus 3 equals 12 minus 2y. So finally, to solve, get all the y's on the same side of the equation. So maybe add the 2y to both sides, and you'll get 5y minus 3 equals 12. And then if you add 3 to both sides, you get 5y equals 15. Divide both sides by 5, and you get y equals 3. And now that you know what y is, you can take that and plug it into one of these equations. You can plug it into either one. I think this one will be nicer because we won't end up with any fractions. So let's see here. 6x equals 12 minus 2y. That's just rewriting this equation right here. And now, instead of writing y, what I'll do is write 3 here because we know y is equal to 3. So we get 6x equals 12 minus 2 times 3 is 6. 6x equals 12 minus 6 is 6. Divide both sides by 6 and you get x equals 1. So for our solution we get 1, 3. Hopefully that was what we got when we graphed. I think it was. Yeah, 1, 3. Good. So far so good. Do this problem one more time. Maybe I'll change colors. And now we'll take care of equation addition. So let's see, for addition, what we'll want to do is figure out something that you can multiply one of these equations by, so that when you write one of these equations right underneath the other equation and add them up, you'll get rid of one of the variables. I think the way I would see this is I'd be like, oh, we have a 6x right here and 1x right here. So I can multiply this equation by -6. And what I'll get, I can leave this guy alone. The only slight change I made is 6x equals 12 minus 2y. 12 minus 2y is the same as -2y plus 12. But I wrote it in this order because now when we write this equation underneath it, the x's, the y's, and the constant term will all line up. And before I write this equation underneath it, I want to multiply it by -6. So if I multiply this equation right here by -6, I get -6x. -6 times y over 2 is -3y. And -6 times -1/2, negative times a negative is a positive. 6 times 1/2 is 3. If you add these up, 6x plus -6x is just 0. -2y plus -3y is -5y. And 12 plus 3 is 15. So let's see, we have an equation here with just numbers and one variable, so we can solve for that variable. I think what I would do is add 5y to both sides. And you get 5y equals 15. and then divide both sides by 5. You get y equals 3. And once you know one of the answers, you can plug it back in. I guess we're going to do exactly what we did right here, right? We have y equals 3, and now we'll plug it into the other equation. So, I don't know, I guess I don't have to do it again. I can say, draw this little line right there, and then this little line right there. Say that my answer is x equals 1, y equals 3. And I got the same answer for all 3 methods, which is a good sign. So I guess I'm done with this problem.